myself Balamuragan. Today we focus on the topic of generation of amplitude modulation. In that, double sideband suppressed carrier modulation, in shortly accounted as DSBSC modulation scheme. We have different type of modulation schemes in amplitude modulations: DSBSC, SSPSC, and VSP. Single sideband suppressed carrier and vestigial sideband. Among the three types, we focus on the first type, double sideband suppressed carrier modulation. DSBSC modulation in general, by their modulation schemes, to multiply the modulation signal to the carrier wave. For their expression, S of t is equal to C of t into M of t. Whereas C of t is the carrier signal with respect to the time period t, and the message signal M of t, M with respect to the time signal t. To multiply carrier signal along with the message signal to get the modulated waveform in time domain S of t, which is equal to C of t into M of t. What is the specialty of DSBSC modulation is that the carrier component is eliminated. The carrier component is eliminated and both upper and lower sidebands are transmitted. Only we need to transmit upper and lower sidebands. By their expression, S of t is equal to, for the second step, AC cos of 2 pi fct into M of t. For that, the carrier signal AC stands for the amplitude of the carrier, and cosine function of 2 pi fct, angular frequency is omega c, which is equal to 2 pi fct, fc into time period is t, and the message signal is M of t. By their concept, the specialty of DSBSC modulation is that the carrier component is suppressed. The power requirement for their transmission is less than that of the in general amplitude modulation. That is one of the major feature in DSBSC modulation. The power required for transmission is less compared to the amplitude modulation. Here the modulation signal, the modulated signal S of t is undergoes a phase reversal. The phase reversal stands for 180-degree phase shift for each time the message signal M of t crosses the zero line. For that moment, the modulated signal, it undergoes a phase reversal. Let me see the DSBSC modulation, double sideband suppressed carrier modulation in a diagrammatic representation. The topmost layer is said to be the carrier wave. Why it is called carrier? Which carries the information, which carries the message signal. In general, the carrier signal is the high frequency signal. Their amplitude is EC. And the second wave said to be the message, original message waveform. Their amplitude is EM. What is the need of, what is mean by modulation? The process of superimposing message signal over to the carrier signal. As we are well known about different type of modulation, amplitude modulation, frequency modulation, phase modulation, in that we are focusing on the amplitude of the carrier is varied according to the message, then it is said to be the amplitude modulation. In that we have the modulation index depends on the modulation index, under modulation, critical modulation, and over modulation. Is M value modulation index is less than 1, under modulation equal to 1, critical modulation, and M is equal to 0, there is no modulation. And M is greater than 1, over modulation. So the third figure illustrates the under modulation, M value is less than 1. So what you are going to observe from the figure A, DSBSC waveform, here each time the message signal crosses to the zero line, the phase to be shifted. Here the phase change is 180-degree phase shifted. And what about the last part, the figure B, the frequency spectrum of the DSBSC modulation scheme? As I told earlier in the previous slide, the carrier signal is suppressed. Only they are going to transmit the lower and upper sidebands with respect to the carrier frequency. Here the carrier frequency is represented as Fc, The lower band is Fc minus Fm and the upper band is Fc plus Fm. So what they're going to transmit for this frequency spectrum, the lower bands and upper bands to be transmitted when the carriers to be suppressed. So it is a specialty of DSBSC modulation. Thereby, the power requirement in DSP modulation is less compared to the general standard amplitude modulation scheme. So that is the best feature in DSBSC modulation. Now let me focus on the Fourier transform of amplitude DSBSC amplitude modulated wave. S of t is given by, is represented as S of f. The Fourier transform wave S of f is equal to AC by 2. Why it is AC? Amplitude of the carrier by 2. The m of message signal of f minus fc, the lower sideband, plus m of f plus fc, that is upper sidebands. Only they are going to transmit lower sidebands and upper sidebands. When baseband signal m of t is limited to the interval, whereas the frequency is minus w2 plus w, the range of frequencies over the interval is minus w2 plus w. From their figure, m of f, here the spectrum is minus w2 plus w. The frequency spectrum is, the Fourier spectrum is S of f is represented the right side of the diagram, where the only they are going to transmit the lower sidebands and upper sidebands. In that, the duration of the transmission bandwidth is 2w. See that the left hand side figure, minus w plus w, therefore w minus of minus w is equal to plus 2w. Therefore, the twice the bandwidth, 2w for the lower sideband bandwidth. Similarly, for the right side, upper sideband bandwidth is 2w. The only changes is that the scaling factor. So what is the scaling factor over here? 1 by 2 AC. Therefore, except for changing the scaling factor, the modulation process translates the spectrum of the baseband signal by frequency of the carrier Fc. The transmission bandwidth required by the DSBSC modulation is same as that of the amplitude modulation. Let me see that how they are going to generate the DSBSB waves with the help of balanced modulator. By their balanced modulator, otherwise called as product modulator. Why it is called so for product modulator? Here the message signal, see the block diagram, the message signal m of t in upper layer m of t and down is minus m of t. Only the phase sign to be changes, positive, negative. We need to consider two AM modulator, amplitude modulator 1 and amplitude modulator 1. So two modulator with respect to the sign changes. The phase reversal is 180-degree phase shift. Here what is the need of oscillator to generate the clock frequency? The carrier signal to be generated with the help of oscillator. Therefore, C of t is equal to AC cos of 2 pi fct. Then that carrier signal is processed by the concept of DSBSC modulation to multiply message with respect to the carrier signal. M of t into C of t we get S1 of t. Similarly, M of t into minus M of t into C of t we can get S2 of t. And to add together, because the S1 of t provides the upper sideband and S2 of t provides the lower sidebands to need to be added together. Now the product modulator output S of t is to be obtained. Now, why it is called by the title balanced modulator, balanced configuration is to suppress the carrier wave. To suppress the carrier wave, to balance the balance configuration, the need of balance configuration, this carrier wave to be suppressed. But the AM modulators are identical for both the cases and upper and lower, except for the sign reversal, M of t and minus M of t of the modulating wave applied to the input. Here the spectrum contains two sidebands of width W, the W with the frequency in terms of hertz. Now let me see the expression of the previous block diagram, S1 of t and S2 of t. So S1 of t is the upper sideband as I told earlier, AC into 1 plus K into M of t into cos of 2 pi ST. Just by multiplying the message signal along with the carrier signal, AC into AC can take outside 1 plus Ka M of t into cos of 2 pi ST. Now what is Ka? Modulation index. And S2 of t is equal to AC. What is AC? Amplitude of the carrier. AC into 1 minus Ka m of t into cos of 2 pi fct. By their adder to subtracting s2 of t from s1 of t. So therefore s of t is equal to s1 of t minus s2 of t. Because the sign reversal, therefore s of t is equal to 2a. By their subtraction what we get 2ka m of t into ac into cos of 2 pi fct. So now we understood what is the difference between amplitude modulator and the help of DSBSC modulator, except for the scaling factor 2ka. Except for the scaling factor 2ka is additionally multiplied over here. The balanced modulator output is equal to the product of modulating wave and to the carrier wave. But other than it is similar for message over the carrier signal. With the help of product modulator, the scaling factor is need to be multiplied to Ka. Now let me see the diagram. The spectrum of the DSBSC wave. Left hand side is the lower sideband and right hand side the upper sideband. So what is the drawback of DSBSC? Double sideband suppressed carrier. It requires the transmission bandwidth is equal to the twice the message bandwidth. So keep listening. Thank you.